A piece of rotating equipment can be as simple as a small electric motor or as complex as this 275 megawatt generating turbine. But all rotating equipment vibrates, and each rotating part within a particular machine also vibrates. Measuring and then analyzing vibration enables you to determine the operating condition of your machinery. Vibration is simply motion, movement back and forth or up and down. It can change in direction and it can change in amount. The amount of vibration is called the amplitude of vibration. Vibration amplitude is a measure of the severity of vibration. The greater the amplitude, the more severe the vibration. Two commonly used measures of vibration amplitude are displacement and velocity. The equipment you'll use to measure vibration amplitude and the procedures you'll follow were designed to fit the particular needs of your facility. So it's important to follow facility procedures carefully. It's good practice to record your readings as you take them, and whenever possible, you should take 3 different readings at each measurement point: a horizontal reading, a vertical reading, and an axial reading. The horizontal and vertical readings are called radial readings because they measure the vibration traveling outwards from the shaft. Axial readings measure the vibration traveling along the length of the shaft. As you might suspect, the severity of vibration is dependent on the type of machine. So, in order to determine whether the measured amplitude is acceptable for a particular piece of equipment, you need to compare your measurements to the specifications for that machine. One common way to evaluate vibration severity is to use a severity chart. You cannot tell from the severity chart, however, what's causing this excessive vibration. The first step in pinpointing the cause of vibration is to identify the frequency at which it's occurring. Frequency is simply the number of cycles in a given period of time. In vibration analysis, frequency is commonly measured in cycles per minute, or CPM. Every rotating part will produce a certain level of vibration that's characteristic of that part, and every machine fault, misalignment, unbalance, and so on, will also produce a characteristic vibration. Monitoring vibration amplitude can alert you to the presence and severity of a problem. Analyzing vibration frequency gives you the basis for determining the nature of a problem. The basic function of a vibration analyzer is to identify the frequencies at which high vibration amplitudes occur. Since equipment and procedures can vary, it's important to follow the manufacturer's instructions for the equipment used in your facility. The filter out setting on a vibration analyzer measures all vibration and gives you an overall picture of vibration severity. The filter on a vibration analyzer filters out all but a specified range of frequencies. Naturally enough, the sharp filter has a narrower range of frequencies than the broad filter. The broad filter on the analyzer allows you to scan through each filter range until you find the frequencies of peak amplitude. Then you can tune in on those particular frequencies with the sharp filter to get the most precise readings possible. These readings will help you pinpoint the source of a problem in your machinery. You can check that you've located all the significant frequencies by comparing the filter-out vibration amplitude with the sum of the filtered vibration amplitudes. Many vibration analyzers record amplitude and frequency readings in the form of a vibration signature. A vibration signature gives you a visual picture of vibration amplitudes at particular frequencies. Since you take readings from 3 directions, you can compare the vibration amplitude on the horizontal, vertical, and axial signatures. This will help in determining the operating condition of your machinery. Vibration analysis is a practical and efficient tool for troubleshooting problems with rotating equipment. The data you collect, the amplitude and direction of vibration and its frequency, give you valuable information about a machine's condition. When you put that information together with your working knowledge of particular machinery, you can eliminate unlikely possibilities and find the most probable cause of excessive vibration. The direction of the vibration can provide a clue as to the cause of vibration, so you can compare the readings taken from the radial and axial positions. This is a simplified drawing showing the pattern that would be produced by offset misalignment. The 2 forces caused by offset misalignment will be picked up by the analyzer probe at 2 times the shaft RPM. This is a simplified drawing showing the pattern that would be produced by angular misalignment. In the case of angular misalignment, only one force is operating on the shafts. This force will be picked up by the analyzer's probe at the shaft's bearing. Since unbalance also occurs at 1 times RPM, you need to look at the direction of the vibration to determine if the problem is unbalance or misalignment. Vibration travels outwards from the shaft's coupling, but because the shafts are rotating at an angle to each other, vibration also travels down the length of the two shafts, causing axial vibration. The analyzer's probe picks up these forces as they're transmitted to the bearing. These two types of misalignment problems, angular and offset, can exist together. In fact, this is much more common than angular or offset misalignment alone. So the presence of both radial and axial vibration is an indication that misalignment may be the problem when high amplitudes of vibration show up at both 1 and 2 times RPM. Usually the amplitude at 1 times RPM will be higher because angular misalignment tends to be more severe, but you'll need to use your practical experience of individual pieces of machinery because more than one type of machine problem can produce similar kinds of vibration. From these examples of common sources of vibration, you can see how important a good working knowledge of your machinery is. Vibration analysis can provide you with valuable information for troubleshooting and maintaining rotating equipment. It can help you eliminate the unlikely possibilities and concentrate on the probable causes of excessive vibration. Applying the information you get from analyzing vibration to particular machines and particular machine problems is the key to using vibration analysis as an effective maintenance tool.